look at the basic setup of how to do any projectile problem. Here's what you got to do. You got to realize that projectile problems are broken into left and right stuff, or x dimension stuff, and it's broken into up and down stuff, which is y dimension stuff. So you're going to make two columns, one for left and right things, that's my x in light blue, and one for up and down things, that's y in purple. Now, what variables do you put under here? What projectile motion is it's kinematics. It's that old kinematic stuff that we've already learned, and we need to use those variables. Now, in the left and right direction, there is no acceleration. A projectile does not accelerate going in the x-axis, on the x dimension or left and right. So we only have three things that we need. We need to know how far, which is d. We need to know how fast, which is v. And we need to know how long, which is t. So distance, velocity, and time are the only letters you have in your x column, because there is no acceleration. So there's no initial or final speed. They're the same. In the y direction, though, there is acceleration. Every projectile accelerates downward at 9.8 meters per second squared. So we need all five kinematics variables. We need the d, we need v naught, we need vf, we need a, and we need t. We need all five. For projectile motion, as long as it's on the planet Earth, we know that the acceleration for every single projectile is downward, negative 9.8 meters per second squared. From here, what we would need to do is we would need to pull from whatever problem we're doing the numbers. We need to decide if it's a left and right number, in which case it belongs in the x column, or if it's an up and down number, meaning it would belong in the y column. Couple of quick little hints. If you are doing horizontal projectile motion, meaning that the object is not launched up or down at all, it's just straight out, then my initial speed in the y would be 0. So just keep a lookout for words like horizontally launched. So the initial speed for that would be 0. If it is launched at an angle, then the direction of that launch might look something like this. This would be where the velocity actually is, in which case we'd have to break it into the x speed and the y speed. You might notice that looks just like a right triangle, because it is. So you would probably be given an angle for the launch. Said, oh, the object was launched 20 degrees above the horizontal or something. So that would be this angle. You would know the speed, the green v. And in order to solve your angled projectile problem, you have to do a right triangle problem first, where you solve for vx, and you solve for vy, and you would plug those velocities in, initial speed, and just speed for both x and y. And that's how you would do that. If you do not remember how to solve a right triangle, check out the How to Solve a Right Triangle video that's in the dynamics section of my webpage, and that'll help you out. Last little bit of information. How do we go about trying to solve these projectile motion problems? It's all about time. Time is the only thing that x and y have in common. Yes, they both have a d, but they're very different. The d in the x is different than the d in the y. The velocity in the x is different than the velocity in the y. But what they do have in common is time. An object can't hit the ground or reach its target in the left and right direction before it reaches that target in the up and down. So the times will be exactly the same. So what will typically happen is go through your problem and figure out what is the question asking. Maybe it's saying, hey, what is the distance in the y direction for this object? So the question mark would be over here on the y. If that's the case, what you're going to end up doing most of the time is solving for time in the x, because you won't have enough information in the y to solve. So if it's asking for something in the y, you're probably going to start with the x, solve for time, and then use that number to solve for what you're actually looking for. And if the question mark is in the x direction, what you're going to do is you're going to start with the y, solve for time, and then use that time over in the x direction to solve what you're looking for. So projectile motion is two kinematics problems. You figure out where your question mark is, go to the other dimension, solve for time using kinematics, plug it in the dimension where you have your question mark, and use kinematics again to solve for your question mark. That's how you do pretty much every single projectile motion problem.